So we're facing a bit of a problem. It's a good problem, but it's still a problem nonetheless. Our manufacturing capacity is limited to our own abilities here at the factory. Unlike most other manufacturers that when they need to make more of a product can just place a larger order with their suppliers, we have to increase our capacity in-house. With the addition of the Sentinel DAC, our machines have been backed up for months and the production queue is only getting longer. Most of our production is based around our Grob 350 Access machine. We love its capabilities, it produces all of our unibody chassis in-house, but we keep running into the limitation of how much material we can get processed through the machine at a time. One of the things that makes it very effective is the addition of a pallet pool. This allows us to store up a lot of different jobs, I think 20 pallets at a time. With that, it can run overnight for up to 24 hours at a time and increase the productivity of this machine significantly. And so we're now getting to the point where the only option to increase the productivity of this machine is to add a second machine. That's really effective in a machine shop environment because it's going to allow you to have a fallback machine that mirrors the same work. So what we're proposing is adding a second Grob machine right here in this space. We're going to lose a lot of storage, but hopefully we'll be able to move a lot more product through two machines. Having identical machines will also allow us to run the same code and the same job setups on both. So if one machine goes down for maintenance or an issue with the spindle, the other machine can continue production and keep our company running smoothly. So we reached out to our sales machine rep and got a quote for a second Grob machine, but the lead time is over 1 year. So with the increased production of the Sentinel DAC, that's simply not going to get us enough throughput in the meantime. So this is the time where we need to take a look at our manufacturing processes and see where we can save time on the spindles and increase throughput on our machines. So we've talked in a previous video about the addition of the Universal Robotics machine arm and the way that took a non-automated machine and increased the throughput dramatically. And so that is kind of the idea of what we're thinking to do with our vertical machines here. These vertical machines run a significant amount of our production, but they require an operator to open the doors and exchange the job that's running on the machine. So if you're running a 30-minute job or a 1-hour job, an operator has to come back to this machine every hour on the dot, process the part, remove it from the machine, take the new material and put it in. So this limits us to when we have staff in the building. And if we're running a 1-hour job, that's only going to be 8 to 10 parts a day. So then we started looking at solutions to automate these machines. They're very expensive and they're very large, and we are limited on space. So if we wanted to add the addition of a robotic pallet pool system that's an off-the-shelf solution, it's going to take up a huge amount of space and limit our ability to add more machines and spindles in the future. As engineers, we're always looking at creative new solutions. And we as engineers also have the ability to implement new solutions that might not be by the book. So one of the first things we did with these machines is add a spindle speeder. So this is a cool technology that basically runs off of the through spindle coolant in the machine. It runs a little turbine that spins the end mill. So it takes a 15K spindle, which is what our machine is, and lets us run it at 60 to 80,000 RPM. So on a product like the Sentinel DAC, we have a jack panel like this. All of the small text engraving is done with this end mill. But the end mill has to run very slowly because the smaller the diameter, the slower the cutting surface. So with a small 20 thousandths end mill engraver, machining some of the text on these jack panels will take up to 30 to 45 minutes apiece. By adding the addition of a spindle speeder, which can run up to 80,000 RPM, we're able to run the end mill 5 times faster. So taking a 45-minute cut and running it down to only 15 minutes to do the same work with the same finish and high quality machining. The approach we don't want to take in a situation like this is to reduce the quality of the parts or the finishes to save time on the machining. So a spindle speeder is a perfect solution to eke out a little bit of extra speed. And we can use them both on the vertical mills and on the Grob 5-axis mill to save time on all of our spindles in the shop. So what we have here is the spindle speeder, and you can see the through coolant jets that come out here. Then that coolant also applies to the cutting edge of the tool, which is like kind of a dual purpose use for this. And then this is then mounted in a hydraulic shunt tendo holder. This here is the hardware required if you wanted an auxiliary pump to come and power this spindle. You can see here the very, very fine tip at the end. That's about a 10,000th tip that we use on this fine engraver. And this is going to do all of the etching work for all of our jack panels and unibody chassis. So that's been an excellent time saver on our spindles. But unfortunately, it's simply not enough because that only works with a few of the small end mill tools. And it saves a marginal amount of time on just a few cuts and not on all of the different work we do here. So we're also going to start experimenting with automating these machines with their own pallet pool systems. But as I said, the off-the-shelf solutions are just far too large and expensive for what they provide. And we have very specific needs and know exactly what we want. So we can design our own bespoke system that supports these machines exactly as we need and maximizes the part throughput for what we're working on. So you can see here, this machine is running a vacuum table. It looks like we're running Cascade base metal right now. But you can see the air hose is going to it. They run a Venturi style vacuum system, and this holds the plates down. But in the Grob, we can't use the vacuum system because as the pallet moves around, there's no vacuum seal for the parts. But what we're planning to do with these machines is to add a robotic arm system that's very gentle and can move a vacuum jig and part without disturbing the alignment of the pieces. We will then also have to integrate alignment into the jig so that when the vacuum is turned on, it sucks the part down into place. The vacuum jig also shares the base plate system. It's a system made by Shunt called the NSL 400. It's a 4-pin system. So if we want to run pallets that don't require the vacuum, we can use the 4-pin system to basically enable a fixed jig. So we use those for parts like top covers and hybrid DAC modules. So you can see the pallet here for the hybrid DAC. There's 5 op1s and 5 op2s, but this is the pin system that we're talking about here. So we need a pallet robot that can move these plates around and install them in the machine itself, but then also work on a vacuum system. So the off-the-shelf solutions will basically give you one or the other, but not both. So if we design our own system, we can make it work with both styles of work holding. Here is what a vacuum plate looks like. Here we have the rubber gasket that outlines the seal for where the plate is mounted. So this is for the Sentinel digital director base metal, the internal metal that provides the EMI shielding. We then have alignment rails on both sides that hold the part in place, and then a support pad for the thinner areas of the part. Underneath, we have the interface of these bushings that align onto the vacuum table. The vacuum table has a tapered pin that will go in each of these holes so that the alignment is repeatable, and that is something that the robot can interface with. Air from the vacuum then passes through these holes and is distributed that suction to the plate itself. So the solution we're considering is the addition of a new robot. So we really love the Universal Robotics. We have experience programming it and we know its control system, but that robot is simply not big enough for what we're talking about. Some of these pallets are up to 50 pounds, and I think the payload for that is about 10 pounds. So Universal Robotics makes the UR20, which is a much bigger robot. I think it'll stand taller than me when it's mounted to the ground. And basically what we're gonna do is we're gonna mount one of those robots outside each machine and then build a custom shelving system. The end of the robot will have a forklift style set of grippers that can pick up either a vacuum plate or a shunt pin system plate. Depending on the program you're running, you will be able to prep up to 12 pallets, I think is what my current design has, and prepare those pieces of metal, and then the robot will automatically interface with the VF2 and swap parts as they get completed. But unlike the lathe, we need this to be a smarter system. So we need to be able to have different jobs running on the same machine. So the robot actually needs to be able to talk to the VF2 directly and say, run this specific program for this pallet, run this specific program for this other pallet. So we're gonna get I think it's called Robot to CNC kit, which allows the robot to basically give actual commands to the VF2 and run specific programs based on their program numbers. So both the NSL 400 shunt system and the vacuum table run off of pneumatic operation. So for the shunt pins, you run a pneumatic pressure to open the pin receiver. So that's something that's very easy to set up with the robot with a little solenoid. And then to pressurize and really seat that pallet, you run a separate pneumatic control that helps pull the pins and make sure there's a secure connection. This will also allow us to check and make sure that the pallet is seated correctly and all the way into place. For the vacuum system, there is always a risk of losing vacuum when running the parts. If you lose vacuum and you're running the part with the spindle in it, it could fling the part off the machine and it's quite dangerous. So one of the cool things is we can get a pressure sensor that the Universal Robotics can monitor. And if it sees that the vacuum seal hasn't been found, so like it puts the pallet in, it goes to seal it down and it's not getting a good enough vacuum connection, it can say, no, I'm not gonna run until that is corrected. So that's a nice safety feature. Then we will also have a hard shutoff system that's independently wired, so a backup system to the VF2 that can hit the e-stop if there's any loss of vacuum. So this gives a little bit of redundancy. So if the robot gets turned off and the part is still running because an operator might be restocking the pallet pool, we have that emergency backup built into the machine just in case something happens to the air pressure. The reason I'm really excited about adding this kind of automation to the VF2s is because it's highly customized to our application. And we're not gonna waste a lot of space in the machine shop with a generic solution that's kind of a one size fits all. And then when it comes to lead time, we're gonna be able to simply buy this robot online, have it delivered, manufacture and CNC cut our own shelving system that has the receivers and connections to center all of the pallets in-house, and program it ourselves in a matter of weeks instead of having to wait 6 months for a large automated system to be installed onto these machines. We really love these kinds of projects. They're very fun for me as an engineer and a designer, and it's a way that we can keep the manufacturing in-house and continually improve our processes, and also make sure that all of our processes are very, very specifically designed to support our manufacturing of products and not wasting space or money on solutions that aren't gonna serve us exactly as we need. I'm really excited to start implementing this robotic pallet system, and this is just the concept phase. We're still laying out the CAD files, how the system's gonna work, how it's gonna connect to the machine. But I wanted to start this video off with kind of giving you an idea from where we're coming at. And then as we do the system and install it, we will bring you along for that journey so you can see all the implementation it takes to take a standard vertical CNC machine and bring it into a fully automated lights out manufacturing CNC platform. If you'd like to see those updates as we work on this installation, please like and subscribe, and we'll catch you in the next video.